Hello everyone, thank you for joining me today for the latest Global Mapper webcast. My name is David McKittrick, Senior Application Specialist here at Blue Marble Geographics. Today we're going to begin what will be a series of webcasts covering the broad theme of LiDAR processing in Global Mapper. When we were planning out our LiDAR processing presentation, we realized there's way more content than we can fit into a single webcast. So we decided we would change our format slightly. Rather than doing an hour-long single presentation, we're going to spread this out over a series of weeks. And each presentation will be around 20 minutes plus or minus, depending on the actual content, and will cover a very specific component of that LiDAR processing capability within the application. So let's take a look at what we're going to be doing over these next few weeks. Well, we're going to begin today with the basic process of importing LiDAR into the application. Now, this is obviously an introductory session for those who haven't used LiDAR before. This will be a good starting point. We're also going to use this opportunity over the next 20 minutes or so to introduce some of the basic structural characteristics of that file format. Again, this is for those of you who have never used LiDAR data before. Following on, the next one we will talk about the LiDAR module. We get a lot of questions as what is a LiDAR module? Do I need the LiDAR module? What functionality does that enable? So we're going to answer those questions in our next presentation. We'll be releasing that hopefully within the next week or so. We will then go into talking about editing and filtering LiDAR data. A major part of LiDAR processing is cleaning it up before you actually do any processing. And we'll talk about the various options we have within Global Mapper and using the LiDAR module for editing and filtering your point cloud data. One of the major components of the module is the process of reclassifying LiDAR. We'll talk about ground classification, we'll talk about building, trees, power lines, we'll talk about some of those automatic reclassification functions. Leading on from that, we will talk about the extraction process, how we can extract polygons, points, lines, depending on the source data, from a point cloud to generate three-dimensional vector features. We will also introduce the custom feature extraction capability, which is essentially three-dimensional digitizing using our perpendicular profiling tool, generating, again, three-dimensional features using your point cloud data. For most LiDAR users, this is going to be an important one, going through that process of changing the structure of your LiDAR from a point-based vector data set into a gridded raster model that will allow you to do things like volume calculations or any sort of terrain analysis, like contour generation as well. So that transitional process from point cloud into surface model, again, probably the most important component, most important workflow for most LiDAR users. We'll cover that one in one of our presentations as well. Wrapping it up at the end, we'll also talk about exporting or sharing LiDAR. Now, obviously, we're going to be beginning the process today by getting data in. It's also important to know how we get data out, whether that be a modified point cloud file. We've maybe made some changes or improvements to that point cloud. We want to get it out in the same format, but we'll also talk about some other mechanisms that are available within the software for making the data available to customers after cleaning it up. So as we saw, the first of those presentations is the idea of importing LiDAR. And this is, again, it's a very introductory session. Not too much technical information in this one. It's a basic process of getting data into Global Mapper. How do we get those point cloud files into the application? So today, specifically, obviously, we'll try to introduce the format. For those of you who have never used LiDAR before, we'll spend a little bit of time talking about some of the characteristics and what LiDAR is. We'll actually hold off on addressing this bullet specifically until a little later, because I think it makes more sense to have loaded some data before we actually take a look at those structural characteristics. We will begin then by talking about where we actually can find data. I know from the folks that we interact with, the folks that we've spoken with, a lot of you have LiDAR data already. Perhaps your state GIS agency or local government authority has provided you with these files. And if that's the case, great, you have the raw material, you have the commodity, you should be good to go. For those who do not have access to data, there are a lot of publicly available files out there, and we'll begin this part of the presentation by talking about how we can access or how we can find some of those data files. The process of loading is obviously important. It's a very simple process in Global Mapper. How do we get that data into the application? And we'll show you a couple of variations on that theme. And as part of that process, we will introduce a number of initial filtering options that are available. You can remove certain types of data. You can limit the extent of the loaded data to a specific geographic area if that's your choice. So we'll talk about some of those initial filtering options. Once we have our sample point cloud loaded, we'll take a look at some of the attribution and some of the metadata. And this will tie into my first bullet where I actually look at some of those characteristics, some of those attribute characteristics, some of the specific components that are available, or specific attributes that are available within our point cloud. We will also talk about how you can generate a point cloud from a non-traditional file. In other words, something that's not recognized as a native LiDAR file. And we're going to talk specifically about a text file. We're going to open up an XYZ text file and create a point cloud or create a LiDAR file from that XYZ file. Now the benefits are improved processing of your data, and also you also have access to some of the LiDAR processing tools that we'll be covering over successive weeks. Originated as a text file, but as you will see, you have the option then to apply some of those more advanced LiDAR processing tools. So transforming an XYZ text file into a LiDAR file, we'll go through that workflow. And as part of that, I want to also introduce a way to determine coverage area. Once we have loaded up a file, we'll see how we can delineate the extent of our coverage and also determine the actual physical area of the point cloud that we're working with. So let's start with the very basics. How do we get LiDAR? Where does LiDAR come from? Well, obviously, as I mentioned previously, you may already have those files. You may have been provided with those files, or maybe a local authority, a local GIS office has them available for you. And if that's the case, great, you're good to go. For those of you who don't, for those of you who need to find files, let's say you're working on a particular project area, how can you find what's available for that area? Now, I'm going to look at a very specific example within the US here. In fact, I'm looking right at the Blue Marble Geographic Office, right here in the middle of my screen. This is where we work every day. Let's assume that my project entails doing some three-dimensional analysis, perhaps terrain analysis within this area. And I want to see if there's any point cloud or LiDAR data available to me. The easiest way for me to do that is to open up the online data option in Global Mapper. Now, those of you who have used this before will probably have used it for streaming imagery or maybe some terrain data, but there's also an option, as you see here, for working with LiDAR point cloud data. Now, we know LiDAR is a vector format, so technically we're not going to be streaming that data into the application, but we're using the same mechanism to essentially query what's available to us at a remote location. Now, I'm going to look specifically at the US National LiDAR dataset, which is hosted by the USGS through the national map. And if I select that option and select Connect, it's going to open up my web browser, and hopefully if the site is cooperating, it will show me a view. I'm going to bring up some imagery, probably a little easier to see here. A view of what I was just looking at in Global Mapper. In other words, it has transposed the area into their browsing window. And specifically what I'm looking for in this situation is some elevation source data. And you can see point cloud data is listed here as an option. So I'm going to quickly ask to find the products. It's searching right now. And within the extent of my project area, it now shows me the files or the tiles of LiDAR that are available. I find it very useful to click the footprint link here, and it will show me the extent, the geographic extent of that data. And if I need to expand that a little, I can choose additional footprint. If I wanted a larger area, for instance, I can choose the next footprint. I can see what coverage I'm going to get through that selection process. Once I have isolated the files that I need, I can simply add them to my cart. And you will need to log in, but you can then download those files and they will be available to you as LAS or LiDAR native files. Now I'm going to close this window because, as I've done many times in the past, we're taking the cooking show approach here. I've already done that. I've already actually accessed those files and I have them sitting in a folder off screen. I'm going to select that file and I'm going to drag it and drop it right into my map view. So the dragging and dropping process is perhaps the simplest way to load up a file. The alternative options would have been from the file menu. We could have selected open, or using the folder right in my toolbar, I could have simply browsed to the file that way. But I usually prefer the drag and drop method. Now, LiDAR is a very unique format. We've engineered Global Mapper to allow us to perform certain filtering options during the import process. And this is very unique to the LiDAR format. This is not available for any of the other formats that Global Mapper supports. And very quickly, I'm going to go through some of the options that are available in here. Well, first of all, we can filter by classification. Every point cloud is going to be attributed, or each point in a point cloud is going to be attributed with a specific class. You may find that your point clouds are mostly ground and unclassified, and we'll probably find the same when we finish the import of this example. There may be additional classes as well, and if you want to initiate a filter during the import process, you certainly have that the option to essentially uncheck the boxes that you don't need, or disable all and check those that you do need. Similarly with return types, if you're dealing with multiple returns per pulse, you can opt which ones to load up. You can also filter geographically. Now, if you have a defined area that you're interested in having the data load within, you can define that based on a loaded polygon or even something that you've previously drawn on the screen, and then you can essentially select that polygon, and it will restrict the loading of the point cloud to the extent of that area. We can also load a preview, give us a sample of our point cloud data just to see what the point cloud structure looks like. We can define elevation range. If we know there are points that are beyond our requirements, we can remove those. We can also remove those that are over a specified number of standard deviations. Again, this is a good way to initially filter the data to remove obvious anomalies within our point cloud. And if we know the point ID, we can also point ID range. We can also define which point ID values to import. At the top of the screen, you'll notice an option or a series of options to bypass the rendering of the point cloud and go straight to creating a grid. And this will enable the functionality that we can use to determine the structural characteristics of that grid. I would typically recommend against this approach. More often than not, when you're loading LiDAR data, you'll want to see those points first, and you'll want to conduct at least a very rudimentary analysis of those points before initiating that gridding process. So I'd strongly suggest you load the point cloud first, and then as a second step, you create that gridded surface or that raster surface layer. So those are some of the options that are available during the import process. I'm simply going to click the OK button now without initiating any filtering, and it will load up the full extent of my point cloud. So now we can go back to my first bullet. My first bullet, if you recall, was what exactly is LiDAR data? What have we loaded here? Let me turn off the imagery, the underlying imagery first. I'm going to zoom out just a little bit, but we'll see the full extent of that tile that we had previewed on the National Map website. Now, in this case, this is a relatively small file. You can see over here in my overlay control center, there's about 2.7 million points within this area. And as we'll see in a minute, we'll get into some of the more in-depth data about this point cloud. We'll see how closely spaced they are, what's the average density of points. To begin a very basic introduction to LiDAR, the best way to do this is to select an individual point. Now we know there's over 2 million. This is a single selected point within this point cloud. And you can see the information that's available at this single point level. We've got the elevation, 70.79 meters in that case. Its class, this tells me which classification it adheres to. You remember during the import process we had the option to filter by class. Well, this is where that class, the class information is stored. The intensity of the return. Now we're going to get into a little bit more of these advanced variables when we go into some of the future LiDAR processing webcasts, but intensity gives us an idea as to the nature of the surface that particular laser reflection was derived from. The scan angle, if you want to determine the angle from the aircraft to the point at which that particular laser pulse hit the ground, you can filter by these values. You can query by these values if necessary. Return count, return number. There is the potential for every laser pulse to have more than one return. In this case, it's a single return. We have 1 of 1, but you may find other points that have multiple returns, and that's typically going to be a reflection of vegetation. If you have a leaf that is in the path of a laser pulse, it's possible that the laser will actually penetrate that leaf, or at least partially penetrate it. It will give a single return from the leaf, but allow partial penetration. So again, you have the option to filter based on that value, but we can see for this individual point, this is a single return from a single pulse. We have GPS time as well, and finally we've got the source ID. So these are just the standard LiDAR attributes. The other thing we can look at in relation to our point cloud is the kind of the bigger picture, the metadata, the overall statistical a summary of what's included in this file. And this is something we can do at the layer level in our Overlay Control Center. I would go as far as to suggest, recommend, that before you embark on any process whereby you analyze this data, maybe create an elevation surface, or do any processing of your point cloud, that you at least visit this component of the application. Now, we can right-click on that LiDAR layer. The lidar.las is the name of the file, and you'll see the option to display the metadata. You can also double-click while holding down your M key on your keyboard. It'll give you the same result. So here's a breakdown of what's included in this point cloud. You can see a confirmation of the number of points, the amount of memory in my computer that's needed to render this, to process this, the approximate density, points per square meter. In this case, it's an approximately 2 points per square meter with an averaged point spacing of about a meter. And that's again a rounded figure for the entire point cloud. We can see variations on the bounding coordinates. We'll get to that when we talk about coverage area in just a little bit. We can see the projection information that's embedded in the file. We can see the maximum and minimum elevation. Now, looking at these values, I can tell immediately that this point cloud is going to need some work. Before I continue and do any processing, I know for a fact that there's no areas in the vicinity of the Blue Marble headquarters here in Maine that are below sea level. Well, I've got a minimum point value of minus 195. So obviously some cleanup is going to need to be done before we proceed. Similarly, we have a maximum elevation of 600 meters. Now, again, this is pretty close to sea level here. We'll go down off to the east a little bit, and we're actually down in a tidal river area. So it's fairly close to sea level. So a value of 619 meters, again, I know is not correct for what we should be seeing here. So we would have to address those issues going forward. But this statistical summary that we can see gives us a little bit more information about what is included in our point cloud. If we move next door to the adjacent tab, you'll see it's called Statistics. This will give us more detail. Now, probably the most useful component of this dialog box is the breakdown of classifications within our point cloud. You can see right off the bat that of the 2.7 million points, we've got almost 1 million that are deemed to be unclassified. Now, in their current form, I really can't use these for any particular process because I can't distinguish what might be a building, what might be a tree, or what might be a person walking along the side of the road. There is no distinction. So this data would have to be processed further to make it useful. Again, later in our webcast series, we'll introduce how we can address these unclassified points and make them more intelligent. You can see the ground points. If our intention is to generate a ground model, we have just under 900,000 ground points natively in this file. So while we have a fairly large file for the area, we saw the point density about 2 points per square meter. The gridded model that we would create from this would be significantly lower resolution simply because not all of our points are available for generating that grid. We would only want to grid our ground points. We have a number of points that are designated as low points, noise points. We have 294 points that are road points. Now, I have a problem with these specifically because, as you can see, the elevation range within my road points is basically the extents that we were looking at previously that are incorrect. So I'm not very confident in these points. I may initially just remove these completely because we know there's erroneous points in those road points. This is an interesting one. According to the way this data was delivered, there are 444,000 points that are bridges. I'll tell you right now, this is not correct. Had we bypassed all of those initial visualization options and gone straight to generating a surface model, we would have lost out on a lot of points which are likely going to be useful. These bridge points could be reclassified as perhaps ground points or maybe even vegetation or buildings depending on our application. So again, this gives me an indication that my point cloud needs a little cleanup, and we will be talking further into our series about some of the procedures we can follow to clean this data up to make it much more useful. Final classification, again, high point noise. This is way more than I would expect to be genuinely noise points. So while the point cloud structurally looks like it's good, it's got a range of classification, the analysis of my statistics would tell me that these classifications are probably not correct. Now, another option that we have for looking at the attributes of our point cloud is to use one of the tools that's inherently available in Global Mapper for searching vector data. Now, we know that Lidar is a vector data format, so we can initiate a search or build a query, if you like, based on that tabular data. Here we have a tabular view of the 2.7 million points, and as you can see, as we scroll down, you'll see all of the attribution listed in a tabular form. We can build a query based on any of these variables, or you can sort. You can simply sort by any of the variables you see in the headings here, and this might be just a simple case of then selecting those that you don't need. You can delete them here, or you can edit them as well. You can apply a different classification perhaps, or remove points that are obviously erroneous points. I'm not going to go any further with this right now because we're dealing with such a large volume of data. The response time is a little slower than it would be for a standard shapefile, for instance. Just so you know, you do have that option again, to address and interact with the tabular display of your attribute data. So the final workflow that we're going to discuss today or explore today is the idea of loading Lidar data or loading point cloud data that is not natively in a recognized Lidar format. Before initiating this, I'm going to unload the data that I have on my screen right now. That was a keyboard shortcut, by the way, Control-U on my keyboard if you want to use that yourself, very useful. And from off screen, I'm going to bring in the file that we'll be using for this last little workflow. It's a very simple file. This is not natively Lidar. Again, I've mentioned that before. This is a text file, but it's a text file with 3 distinct delimited values. We have an X value, we have a Y value, and outside the final comma here, we have a Z value. So what we're going to do is we're going to load this file into Global Mapper. Now, if it were just points, points representing assets or locations, we could simply bring it in as points. That would be fine. But because we know this has elevation values, we're going to select a slightly different procedure. This is our standard text import dialog box. This is how we can generate, as I mentioned, points, or we can connect those points to make lines or polygons if necessary. We've covered some of these procedures in some of our other presentations. Today what we're going to do is choose the final option, where we're going to pretend that that text file is actually a point cloud. Some of the other options we need to set here are the coordinate order. I know my easting is first, so I'll leave that exactly as it is. We know the final coordinate, the third coordinate, is an elevation. We want to make sure this is checked. We don't have any additional attributes. Now, if we wanted to, or if we had them available, we could add things like intensity or color to our point cloud natively by having those as additional columns. Well, we don't have any of those, so we'll uncheck that option. Everything else here should be fine. We'll click OK. Now, the final selection we need to make is what those X and Y values are. Well, I know, based on my knowledge, that this is a UTM, a series of UTM coordinates, and importantly in this case that the elevation units of that third value are meters. So we'll make sure those are selected. This is UTM zone 19, which is right here in the state of Maine, and elevation units meters. We'll click OK, and this file now loads as a point cloud. Now you may have noticed that it renders almost instantly. In the context of Lidar, it's not a very large file. It's only 157,000. So, as we know, point clouds, Lidar point clouds can be millions, sometimes even billions of points. This is relatively small in that context. But if we had tried to load 157,000 text points as a text file, we would likely still be waiting for those to be rendered. So there are inherent benefits in loading XYZ data and making it Lidar data. Now, over and above just the speed, there's also the access to some of those other tools that we will cover through our next in our series of webcasts, things like filtering and recognizing ground points within this point cloud. But obviously you can see as a loading option, it's much faster to load an XYZ file in Lidar format than it is in text format. Now, the final bullet in my list for today, and my to-do list or my agenda for today, was to determine coverage area. We saw previously in our metadata, there's a numeric value that's calculated dynamically that tells us what our coverage is. One of the really nice things that we can do, and really nice tools, not exclusive to LiDAR, but certainly very useful in this context, is actually to delineate coverage. Now, in this example, I chose a file that is not regular. The previous example, my LiDAR file, was a tile, so it was uniformly rectangular. In this example, it's not. So what I want to do is delineate the extent of this point cloud. And I can do this using my right-click option. If I go all the way to Layer, there's an option that allows me to create a bounding box. Now I can also access this tool from the Layer menu, which is up along the top of my screen there. Same result. If we choose this option, we're going to be given two options. One is to create a rectangular area. Now that would essentially be the MBR, the minimum bounding rectangle that would encompass the extent of this layer. I also have the option to choose a polygon coverage area, which is what I'm going to do in this case. And further to that, I can also choose how close to the data that's in this layer, in this case it's my points, that I want the outline to be created. Smooth and rough, it's just a slider bar. I would typically keep this close to rough because it will more precisely give me the coverage, generate a polygon that mirrors the coverage I'm seeing in this point cloud. So we'll click OK. It will generate that polygon coverage area, and probably the easiest way to see this is to turn off the point cloud. I now have a delineated outline for the extent of my data. Really nice thing about this is during that process, it actually adds the attribution of the layer to the polygon that was created. You'll see when I try to access those attributes, I'm being prompted with the option to load a URL to open a selected value. One of the attributes that's added is actually the path to the file that I just delineated. Now this is a useful tool in and of itself because I could then generate a hyperlink that would allow me to load the point cloud that is represented by this polygon. If I have multiple tiles of LiDAR, I could then create essentially an index layer of polygons, click on the index layer, choose to open that file in Global Mapper, and my point cloud will be rendered right, obviously at the right location. I'm going to bypass that because I simply want to look at the information itself. Now this is the information that was automatically added to this polygon during that bounding box process. This is the link I told you about previously. This is where this file happens to be located right on my desktop. Other information mirrors what we saw previously in the metadata. The count of points, the memory required, the point spacing in this case, all the way down to the projection information. All of that information is now embedded in this polygon that was automatically generated for us. So those were some of the basic procedures for loading LiDAR data. And truthfully, loading files is not difficult. As you saw, dragging and dropping, very efficient way to load data, not only LiDAR data, but any file into Global Mapper. Obviously, LiDAR is fairly unique. It had its own dialog box, allowing you those filtering options. Hopefully, now that you know that there's more to LiDAR than just superficial data, you'll need to do a little bit of analysis of what's included in your point cloud before you perform those filters. In our case, we saw there's a lot of points that were incorrect. Process of loading an XYZ file, exactly the same. Very simple, but again, the benefit being it now is considered LiDAR, much more efficient to work with. Next time out, we're going to take a look at the LiDAR module, and we're going to start getting into some of the more advanced visualization options, some of the more advanced extraction options. But by way of starting the process, we'll show how to activate the LiDAR module. So we'll cover that next in our next session. If you have any questions about any of this content, best bet is to contact the folks on our tech support team. GeoHelp at bluemarblegeo.com is your best option. If you are not currently a user of Global Mapper and you want to inquire about some of the licensing options, we've just recently introduced academic licensing. Basically, it's now available at no cost for classroom use in U.S. schools and colleges. So if you're interested in that option, folks in the sales group, orders at bluemarblegeo.com. We'd love to talk to you. And if you're not currently using the application, you can certainly download a trial of the software. It's a 2-week trial. And as I said, we'll introduce the LiDAR module next week. You can also try out the LiDAR module for free as well. So that covers us for today. Thanks for taking the time, and I will speak to you next time.